Hello everyone, it's Mr. Wolfe here, and in this video I'm going to be explaining number 2 on page 25 of your Unit 2 packet. So in this case, a tow truck is pulling a broken car. I'm going to start drawing my free body diagram. So if it's pulling the car, it's going to be on a surface. So I draw that with my dotted line. Initially, I know that I'm on Earth, so I'm going to draw my force of gravity going down. It's against a surface, so I'm going to have the surface pushing back with the normal force right here. And it says tow truck is pulling a broken car to the left with a force of 3,000 newtons. So that seems like it's going to be my force push. And I could just label that with 3,000 newtons right here. Right, the force of friction on the car is 2,200 newtons. So in terms of what direction that's going to go, I have to use my purple sheet and say, well, force of friction is always going to be parallel to my surface, and it's always going to be going against my intended motion. My intended motion is to the left, so the force of friction is to the right. Now, in terms of how big I draw this arrow, I'm going to draw it smaller because 2,200 is less than 3,000 newtons of my force push. So something like that, 2,200 newtons. All right. Now I'm just going to try to get my bearing straight and say, all right, let's draw my F net x equation. It's always your positive minus your negative forces, or in this specifically, your force is going to the right minus your force is going to the left. So it's going to be your force, and I didn't label this before, force of friction minus my force push in the x direction, horizontal direction, and in the vertical direction, y direction, positive forces minus your negative forces, your forces going up, so normal force minus your forces going down. All right. Draw the arrows that represent the following. In this case, I'm going to be looking for, since everything kind of balances out up and down, I'm going to be looking for my net force to the left and right. So if my force push is bigger than my force of friction, just kind of conceptually, I know that my net force is going to have to go to the left. Newton's second law says that whatever your net force is, it's going to cause an acceleration that goes in the exact same direction. And then we can imagine if you're towing a car, it was at rest before. So now with a net force and acceleration going to the left, the velocity is going to be going to the left as well, and our object should be increasing speed. The velocity and acceleration are in the same direction. All right, so now let's actually figure out what this problem is asking. Calculate the mass of the car. So my equation that we only have this far is F net. Acceleration is equal to F net divided by mass. So I know that this is the variable that I'm going to be looking for. All right. And let's see, do I have any numbers off the bat? A car accelerates at a rate of 0.44 meters per second squared. So those are my units for acceleration as well. So I'm going to say 0.44 is my acceleration. Looking for mass. All right, what's my net force? It doesn't say it specifically in this problem yet. So I'm going to have to find it. I'm going to look for it in the x direction right here. So F net x, and I already wrote out the equation, so technically you don't have to do this again, but I will. All right, my force of friction, which is 2,200 newtons minus 3,000 newtons. And I'm going to get a net force of 800 newtons, but it's going to be negative 800 newtons, right? And that makes sense. My net force should be going to the left. I should get a negative number. So I'm going to take this, and I'm going to plug it in for net force. Negative 800 newtons divided by mass. So if I were to kind of just simplify all this right here, 0.44 is my acceleration, negative 800, mass right here. All right, so then how do you solve this mathematically? You want to get mass by itself, but you also don't want mass in the denominator. So I'm going to multiply mass by both sides. These cross out. So then it ends up being mass times 0.44 is equal to negative 800. Now I want to get mass by itself. So I'm going to divide 0.44 by both sides. They cancel out right here. So then it is negative 800 divided by 0.44. And you're going to get a mass of 1,818 kilograms. Right? But if I did this, I would get a negative number. And right off the bat, I know that mass can't be negative. Like you can't have direction towards mass. It's just the amount of stuff an object has. So I'm going to go back and I say, like, what maybe did I do wrong here? The negative 800 makes sense. My net force is going to the left. The 0.44, my acceleration though, that doesn't make sense though. That should be a negative acceleration, right? Just based on this conceptually. So I should have earlier put a negative here, right? That makes this negative. That makes this negative. So a negative divided by a negative would give me a positive mass. Right? So I kind of did this on purpose just to kind of show that if you get a number that doesn't make sense, like a negative mass, go back and did you forget to make another number negative? In this case, it was supposed to be the acceleration. So my mass of my object is going to be 1,818 kilograms.